In this session, we are going to discuss one very important section of quantitative aptitude, which is data interpretation. In some exams, data interpretation is a separate section by itself, but in bank exams, it forms a part of quantitative aptitude, and its weightage varies from 10 to 45 marks. So very clearly, data interpretation is one very important part of quantitative aptitude section in bank exams. As the name says, data interpretation is nothing but interpretation or analysis of the given data to get some useful information. Data, as we know, refers to facts or figures which have been collected for analysis and decision making. Data in general is in a raw form, but it can be arranged and presented in an organized or systematic manner with the help of various charts and graphs so that useful information can be extracted from it. So in this session of data interpretation, we shall see what are the various forms in which the data can be represented and how can we extract information out of it. Let us quickly look at what are the various forms in which the data can be presented in a structured manner. Now, the various ways of data presentation is as follows. First one is tables, the second one here is pie charts or circle graphs, third one is bar graphs, fourth one is line graphs, and the fifth one here is mixed graphs. So generally these are the 5 different ways in which the data can be presented. Now tables, as we know, is the most convenient and compact way of representing the given data, where the information is provided in terms of rows and columns of a given table. The next one here is pie charts or circle graphs, where a complete circle is divided into different sectors based on various percentages. The third one here is bar graphs, or it is also called histograms, where the information is given in terms of a bar graph, where each bar represents some quantity or figures in the given information. The fourth one is a line graph, which is nothing but a Cartesian graph or a XY plot, where the information is shown in terms of a line in the XY plot. And the last one, as you can see here, is mixed graph, which is nothing but a combination of any of the above 4. For example, in some cases, the information is given in terms of a table along with a line graph. So table shows some part of the information and a relevant information is given in the line graph. And in some cases, we find pie charts are given along with line graphs or bar graphs or tables. So any combination of the above 4 types of graphs or charts is called a mixed graph. Before we take up any question from data interpretation, let us quickly look at what are the various concepts required for solving different questions from data interpretation. All these concepts have already been discussed in various topics like percentages, averages, and ratios, but before we start, let us quickly revise each one of them. Mostly the questions asked from data interpretation are from 3 areas. One is averages, second one is ratios, and the third one is percentages. From averages, the commonly asked question is to find out the average of the given values. We know that average is nothing but sum of all the values by number of values. For example, let's say the data presented in the form of chart or graph is talking about the profit of a company from 2001 to 2010. So the question may be, what is the average profit of the company? So average profit of the company is nothing but sum of all the profits from 2001 to 2010 divided by the number of profits. That is nothing but sum of all the values by number of values. The second commonly asked question from data interpretation is from ratio. Ratio, we know, is represented as A is to B. It is nothing but a comparison of like terms in its simplest form. Let us again consider that the profit of a company is given for various years. Now the question may say, what is the ratio of profit made in 2004 is to the profit in 2007? So we simply need to take these 2 values and find out the ratio. Or it may be, what is the ratio of sum of the profits in 2001 and 2003 to the profits in 2004 and 2007. So 2001 and 2003 profit taken together, 2004 and 2007 profit taken together, the ratio has to be calculated. So that's how we can solve questions from ratios. And the last one here is percentage. The most commonly asked questions from data interpretation is from the topic of percentages. And within percentages, we have 2 or 3 different concepts which are generally asked in DI or data interpretation. So let us quickly revise each of these concepts which have already been discussed in the topic of percentages. Now the first one here is X is what percent of Y. It should always be taken as X by Y into 100. This is the most frequently asked question in any form of data interpretation. That is, X is what percent of Y. We should always take it as X by Y into 100. For example, let's say the question is profit in 2003 is what percent of total profit. So profit in 2003 by total profit into 100 should be the answer. Or likewise, profit in 2007 is what percent of profit in 2009. So profit in 2007 by profit in 2009 into 100. So we simply need to pick up the values from the given data, substitute in x by y into 100 and find out the required answer. The second question from percentages could be x is what percent more or less than y. X is what percent more than y or x is what percent less than y. This can be taken as x minus y by y into 100. For example, the profit of 2010 is what percent more than the profit of 2008. So profit of 10 is what percent more than 8. So profit in 2010 minus profit in 2008 by profit in 2008 into 100. So simply pick up the values from the given data, substitute in the formula and get the required answer. And here again, the answer may be percentage more or percentage less depending on the sign of the magnitude. For example, if you get a positive answer, it means it is percentage more. And if you get a negative answer, that shows it is percentage less. And the last, but again an important one here is percentage change. Percentage change, as we have learned in the topic of percentages, is nothing but final value minus initial value by initial value into 100. This is again a very frequently asked question from DI. Percentage change, final value minus initial value by initial value into 100, or it can be taken as difference by initial value into 100. Difference is nothing but the final value minus initial value. So difference by initial value into 100 or final value minus initial value by initial value into 100. For example, let's say for the given data, that is profit of a company for the given years, the question is what is the percentage change from 2001 to 2007? So as you know, the initial value here would be the profit in 2001 and final value will be the profit in 2007. So 2007 profit minus 2001 profit by 2001 profit into 100. Or the difference between those two profits divided by the initial value into 100. So this is how percentage change, which can be either a percentage increase or it can be a percentage decrease. It can be always taken as final value minus initial value by initial value into 100. So again, we just need to decide what are the two values there, substitute here and get the required answer. Percentage change again can be asked in three different formats. One is percentage change from a given year to some other year. That means in this format, both the years have been specified. So we can clearly decide what is initial value and what is final value. The one which comes first should be taken as initial value. The one which comes in a later year should be taken as final value. So simply substitute and get the answer. So that's the first way of asking percentage change, where both the years have been clearly mentioned in the question. So we only have to pick up those relevant values, substitute and get the answer. The second way is by giving only 1 year in the question. For example, the question may be what is the percentage change in the profit of the company in the year 2006? Percentage change in the profit of the company in the year 2006. Now here only 1 year has been specified. Remember friends, whenever only 1 year has been given in the question, we generally calculate the percentage change with respect to the previous year. So when it simply says percentage change in 2006, it has to be taken with respect to 2005. So final value would be the value in 2006 and initial value will be the value in 2005. Likewise, the question can say what is the percentage increase or percentage decrease in 2013. So only 1 year, 2013 has been given. So change should be with respect to previous year when nothing has been specified. So previous year will be 2012. So final value can be taken as the value in the year 2013 and initial value should be taken as the value in 2012. And by taking those in the formula here, we can find out the answer. So that's the second model where only 1 year is specified. And the last one here is the one in which both the years have not been given. The question simply says find out the percentage change or percentage increase or percentage decrease over the years. Remember friends, whenever the phrase over the years is used, we always consider the first year as initial value and the last year as final value. For example, let's say the data is given from 2001 to 2010, profit of a company or population of a country from 2001 to 2010. And the question says what is the percentage increase in the profit or what is the percentage increase in the population over the years. So when it says over the years, initial value should be the first year value, that is 2001 as in this case, and final value should be the value in last year, that is 2010. So final value is last year value, initial value is first year value. By again substituting the values here, we can find out the required answer. So this is a very commonly asked question, percentage change, final minus initial by initial into 100. Generally, percentage change is asked in case of bar graphs or line graphs. But all these types of questions are important when it comes to any form of data that is given in data interpretation. So be it tables or line graphs or bar graphs or pie charts or mixed graphs for that matter, these are the various topics which are covered in case of data interpretation. Apart from these concepts, the other questions that are asked in data interpretation are self-explanatory. That is, we simply read the question, understand and get the required answer. And as the weightage of this particular section is very high, the score of this subject, that is quantitative aptitude, automatically shoots up if you are good in this particular area. So make sure that you practice well on calculations so that solving various questions from data interpretation becomes an easy task. Let us now take the first module from data interpretation, where we are going to discuss a question based on information given in a table. Tables, as I've earlier mentioned, is the easiest and most convenient way of presenting the data if the given data is reasonably limited. Tables present the data in a logical way, and it presents a bird's eye view of the given data in a very concise and compact manner, and hence helps us save a lot of time and space. So let us take an example based on the information given in table and see how to answer questions based on that. As you can see here, we have a table with 4 columns. The first column showing professions, second one percentage of people, the third one is percentage of females, and the fourth one says percentage of males. And the information here reads total 24,500 people who are in given professions. As you can see, the given professions are medical, engineering, law, teaching, banking, and the last one is management. And of these, percentage of females and males. That means if we try to observe, we have 6 professions. For each profession, the percentage of people is given, percentage of females and percentage of males is also given. And total number of people here is 24,500. For example, if we take the medical profession, the table says 11% of the people are in medical profession. Now this 11% is of 24,500. So if we have to find out the number of people in medical profession, we can say it should be 11% of 24,500. Similarly, how many people are there in banking profession? That is equal to 16% of 24,500 people. So 16% of 24,500 will give us the number of people who are in banking profession. Likewise, by taking the percentages with respect to 24,500, we can find out the number of people in various other professions. Now the third and fourth column, as mentioned here, shows percentage of females and percentage of males. For example, for medical profession, 60% are females and 40% are males. 60 plus 40, as you can see, total here is 100. So out of 100% people in medical profession, 60% are females and 40% are males. So if we have to find out the number of females in medical profession, we take it as 60% of the number of people in medical profession. Remember, it should not be taken as 60% of 24,500. Why? Because this 60% here is not with respect to total number of people. This 60% is with respect to number of people in medical, that is 11%. So the number of females in medical profession will be 60% of 11% of 24,500. Likewise, number of males will be 40% of total people in medical profession, but not 40% of actual total number of people. So it should be taken as 40% of 11% of 24,500. Likewise, for various other professions as well, we can find out the number of females and number of males by the given percentages. So this table clearly shows us how many people are there in each of the professions. It is given with respect to the percentage, and all those percentages should be taken for 24,500. And apart from that, we can also find out the number of females and number of males from each of these professions. Let us now look at the various questions that have been asked with this table. The first question here is, what is the ratio of total number of males in medical and teaching professions together to the total number of females in the same professions together? So here we have to find out ratio. As I mentioned, one of the important topics when it comes to data interpretation is ratio. So we need to find out the ratio of total number of males in medical and teaching professions together to the total number of females in the same professions together. So this ratio here is with respect to males and females. Males in medical and teaching together is to females in medical and teaching together. So we can say that the answer should be number of males in medical plus teaching is to number of females in medical plus teaching. So let us find out each of these values and see what is the answer for this question. Now, the first part that is required is males in medical profession. As we know, the total number of people in medical profession is 11%. 11% of 24,500. And out of those number of people in medical, 40% are males. So the number of males in medical can be taken as 40% of 11% of 24,500. So the first part here, males in medical, is 40% of 11% of 24,500. Plus, the second part is males in teaching. Again, going by the same concept, we can say that males in teaching will be 20% of 21% of 24,500. So this will be equal to 20% of 21% of 24,500. So this is the total number of males in medical as well as teaching. That's the first part in the ratio. And the second part here is the females in the same two professions. Now, an important point that we can observe here is to find out the females in the same two professions, we need not refer the table again and waste our time. Once we have calculated the number of males from the same values, we can also decide what will be the females value. For example, in medical profession, we know 40% are males. So it is obvious that remaining 60% have to be females. So directly we can say it should be 60%. And remaining part remains same, 11% of 24,500. So 11% of 24,500. Plus, if 20% are males in teaching profession, remaining 80% will be females in the same profession. So we can say it is 80% of 21% of 24,500. And again, the second part remains same. 21% of 24,500 is total number of people in teaching. So whether it is for males or for females, total will remain same. So the point that we have seen is, instead of looking at again how many are females, 60% of 11% of 24,500, directly we can say if this is 40, this should be 60. Likewise, instead of again referring the table and checking that this is 80%, directly we can say that 20% here, that means 80% will be for the females. So this way you will not save a lot of time, but at least few seconds can be saved by not referring the table and taking the values directly. And this can be done only when the professions for males and females are same in the given ratio. Otherwise, we cannot take it directly and we have to refer the table and mark the values. Let us now try to simplify this and get the required answer. Now, if we try to observe, this 24,500 is common on the males part as well as on the females part. So very clearly, this can be cancelled on both the sides. Remember friends, ratio is a comparison of like terms in its simplest form. So simplest form means whatever is common has to be cancelled out. So here we find that 24,500 is common for male side as well as for female side in both the professions. So we simply strike it off. At the same time, you can also observe that these percentages are also there on both the sides. Percentage is nothing but by 100. So instead of taking it as percentage, let us simply take the magnitude there. Why? Because here we have 40%, that is 40 by 100 into 11 by 100. Here also 20 by 100 into 21 by 100. Here again 60 by 100, 11 by 100, 80 by 100, 21 by 100. So those divided by 100 gets cancelled on both the sides. So directly we can say that percentages here again doesn't affect the calculation. So if we really try to observe, the only calculation that we need to do here is 40 into 11 plus 20 into 21. 20 into 21. This is to 60 into 11 plus 80 into 21. Now by simplifying this, we can find out the required answer. Now an important point that we need to understand here is, when we are solving this question in the exam, there doesn't make any sense by writing 24,500 initially and then cancelling it out. Likewise, by taking percentages initially and then cancelling it out. We should be efficient enough to analyze and directly take what will affect the answer. For example, here we know that when we are talking about males in different professions, only the percentage of males and the percentage of people in those professions will be required. That is, males in medical, 40 and 11 is what is relevant. Similarly, males in teaching 20 into 21 is what is required. Likewise, for females also we can say that 60 into 11 and 80 into 21 is what will be actually the thing to be simplified. Now let us try to simplify this and see what the answer is. If we take 20 common, we see that this is 20 into 2, 20 into 1, 20 into 3 and 20 into 4. So this becomes 2 into 11, 22 plus 1 into 21, 21. So 22 plus 21 is 2, 3 into 11 is 33 plus 4 into 21 is 84. So 22 plus 21 will be equal to 43 is to 33 plus 84 will be 117. So we can say that the answer for this question is 43 is to 117. Remember, you do not write this step in the exam. Directly you should be able to take this in the simplification and simplify that to get the required answer. Let us now take the second question for the given table. The question here is the total number of people in teaching profession is what percent of total number of people in law. So as you can see here, the total number of people in teaching profession is what percent of total number of people in law. Now if you observe, this question is in the form of x is what percent of y. We know that x is what percent of y should be taken as x by y into 100. Now with respect to this question, x is nothing but total number of people in teaching profession is what percent of, and y is total number of people in law. So this question is like the number of people in teaching is what percent of number of people in law. So the answer should be taken as total number of people in teaching divided by total number of people in law into 100. Now if you observe the table here, number of people in teaching is 21% of 24,500 and number of people in law is 24% of 24,500. But again we can understand that the 24,500 is common for numerator and denominator. So that anyway is going to get cancelled. So the only values that will affect the answer here is 21% for teaching and 24% for law. So we can directly say that the answer here will be 21% divided by 24% into 100. Even these percentages here are not required. Why? Because only the magnitude is what will give us the answer here. Percentage gets cancelled in numerator and denominator. Now by simplifying 24 by 24 we get 7 by 8. This is 3 into 7, 21 and 3 into 8, 28. So the answer here is 7 by 8 into 100. And from the knowledge of percentages we know that 7 by 8, that is the fraction 7 by 8 is equivalent to 87.5%. So that's the answer for this question. That means the number of people in teaching profession is 87.5% of the number of people in law. That is the answer for this question. The third question from the table here is what is the total number of males from all the professions together? Now this is a very simple one. What is the total number of males from all the professions together? That means we need to find out the number of males in each of the professions and add all these values to get the total number of males. We very well know how to find out the number of males for each of the professions from the given table. From the first column here, we know percentage of people in each of the professions. And from the last one here, we know percentage of males for each of the professions. So by using both these, we can find out the number of males in each of the professions. For example, number of males in medical is nothing but 40% of 11% of 24,500. Number of males in engineering, 70% of 18% of 24,500. Likewise, for remaining professions as well, we can find out the number of males and then add all these values to find out the required answer. Now just try to understand, friends. You know that on an average, we have about 30 to 36 seconds to solve a question in the exam. And this particular question, though it appears to be simple, in the beginning itself I mentioned that this is a simple question. What is total number of males from all the professions together? Though it appears to be simple, the calculation here takes a lot of time. Why? Because overall if you observe, the complete calculation has to be done. We cannot eliminate anything here. We cannot cancel out any of the numbers. It should be taken totally as 40% of 11% of 24,500 plus 70% of 18% of 24,500 plus 55% of 24% of 24,500 plus 20% of 21% of 24,500 plus 65% of 16% of 24,500 plus 56% of 10% of 24,500. At the maximum what we can do is take 24,500 common, but still the calculation there would take a lot of time. And it is not so easy that we can do the complete calculation and get the answer in less than 30 or 45 seconds. Even if we try to go for approximate calculations, you see that options are given in such a way that approximate calculation will not help us. And fifth option, moreover, is none of these. So we have to do the exact calculation if you want to answer the question. And that would take at least 1 to 2 minutes to get the answer there. So the best way to solve the question here is leave it and go to the next one. Remember, there may be 1 or 2 questions out of the given 5 questions which are difficult to solve. Difficulty here is only in terms of consumption of time. Question is easy, but calculation takes a lot of time. You cannot do the calculation in less than 30-45 seconds and mark the answer. Such questions have to be left if you want to score more. Remember friends, if you solve this question, you may get 1 mark. But if you leave this question, you will get at least 2 to 3 marks in the same time that you have spent for this question. So whenever you find such questions, the best solution there is leave it. Hence, this question still remains a simple one. The simple solution is we will not solve it. Just leave it and go to the next one. The fourth question for the given table is, the females in the engineering profession are what % of males in the management profession? So this again is like females in engineering profession. X is what % of males in management profession. Y. X is what % of Y. We know that X is what % of Y should be taken as X by Y into 100. So females in engineering are what % of males in management? Answer should be females of engineering profession divided by males of management profession into 100. X by Y into 100. Remember friends, when you are solving this question in the exam, there is no point in writing females of engineering by males of management into 100. Here I am writing this only so that we can understand the calculation. Otherwise, you directly need to put the numbers there and do the calculation, mark the answer, go to the next one. So the answer here should be females of engineering profession by males of management profession multiplied with 100. Now by table, we know that females in engineering is 30% of 18% of 24,500, and males in management is 56% of 10% of 24,500. And we have already discussed that whatever is common in numerator and denominator will anyway get cancelled. So here, as 24,500 gets cancelled in the numerator and denominator, let us concentrate only on the percentages for females and males of the professions engineering and management respectively, and the percentage of people in these two professions. Why? Because these are the only values that will affect the answer. So females of engineering can be taken as 30 into 18. Let us not even take those percentages. Why? Because anyway that percentage gets cancelled in numerator and denominator. So this is 30 into 18, females of engineering, and males of management. Males of management is 56 into 10. 56 into 10 into 100. Remember friends, had the two professions been same, for example, females of engineering by males of engineering, we would not have taken these percentages as well. Why? Because even those get cancelled. But since the professions are different, we not only have to take percentages of males and females, but also the percentages of each of those professions. So the actual answer here will be 30 into 18 by 56 into 10 into 100. Now upon simplification, we can see what is the correct answer. Now zeros anyway here get cancelled. We get 3 into 18. 3 into 18 is 54 by 56 into 100. Now from the knowledge of percentages, we know that 54 by 56 into 100 is very close to 100%. Why? Because numerator and denominator here are close to each other. We can say that approximately 54 is 56. So this becomes 56 by 56, that is 1. 1 into 100 is 100%. So approximate answer here will be 100%. And actual answer should be less than 100%. Why? Because numerator is slightly less than denominator. So something which is slightly less than 100% can be taken as the correct answer. If you look at the options, no way first option 71.71 is correct. Why? Because answer should be close to 100%. This is far away from 100. Even fourth option 68.54 would be wrong. And third option 83.16 is also wrong. The possible answers here are either second option 96.43 or the fifth option none of this. Now if we try to go for a precise calculation, we find that 96.43 would be correct. So we can say that the answer here is 96.43%. So upon simplification, we say second option is the correct answer. But one important point that I would like to mention here is, while solving these questions, if we are running short of time, let's say we are doing this in the last 3 or 4 minutes of the exam, there in such situations, it would be better that you directly mark 96.43 as the answer without doing the actual calculation. Why? Because anyway, the remaining 3 options have been ruled out. The answer should either be second option or fifth option. And probably it has to be second option only. Why? Because it is close to 100% and it satisfies the conditions here. So instead of doing the complete calculation and wasting your time in such situations, you better take a chance and mark second option. Let me tell you friends, you may go wrong also. But then instead of wasting time on this question itself, we can move to the next one. And there are fair chances that will be correct. 50-50 probability that either second option or fifth option is correct. And if you are smart in calculation, by looking at these numbers, you can understand that it should be between 96 and 97. Why? Because 56 should be taken as 100%. Always denominator should be taken as 100%. So if 56 is 100%, we can say that 1% is 0.56. And 0.56 into 4 is approximately 2. So this 54 here, it can be taken as 56 minus 2, that is 100% minus approximately 4%. 100% minus 4% is 96%. So answer should be close to 96%. And hence, second option can be marked as the answer. So try to be smart and do the calculation without writing all the steps on paper. Remember, always denominator should be taken as 100%. And with respect to this 100%, we should be able to decide what is the numerator in terms of percentage. So if denominator is 100%, 56 is 100%. 1% is 0.56. 0.56 into 4 is approximately 2. Why? Because 0.5 into 4 is exactly 2. So we can say this 54, which appears like 56 minus 2, is 100% minus 2 is 4%. So 100 minus 4 will give us 96 as the approximate answer. So that can be taken as the correct answer. The question here is, what is the ratio of number of males in the banking profession to the number of males in engineering profession? So this again is a question on ratio. We have to find out the ratio of males in banking to the males in engineering. So males in banking is to males in engineering. Remember, I had mentioned that we need not write these steps while solving the question in the exam. Don't waste your time. Cut short the number of steps. Here I am writing this only so that we can understand the calculation. Otherwise, if you have understood the question, you better directly take the numbers and solve it to get the answer. But don't waste your time in writing all these things there. Now, males in banking. We know that males in banking is 65% of 16% of 24,500. And males in engineering will be 70% of 18% of 24,500. And we have already learned that whenever something is common in the numerator and denominator, or in the two parts of the ratio, that has to be cancelled out. So instead of writing and then cancelling it, let us directly take only those values which can affect the answer. That is percentage of males and percentage of people in these professions. So males in banking can be directly taken as 65 into 16. So this is 65 into 16 is to males in engineering can be taken as 70 into 18. This is 70 into 18. We are not taking 24,500 or percentages for each of these values. Why? Because it is anyway common on both the sides and gets cancelled. Now by simplifying this, we get the required answer. 65 is 13 into 5 and this is 14 into 5. 16 and 18 can be taken as 2 into 8, 2 into 9. And this can again be taken as 4 times and 7 times. So 13 into 4 is 52 and 7 into 9 is 63. And this cannot be simplified further. So we can say that the answer here is 52 is 63. But remember, what you write in the exam is directly this step, simplify and mark the answer. That is 52 is to 63. So remember, these are the types of questions that we get from data interpretation. It can be either from ratios or from percentages or from averages. So as you have seen from all these 5 questions, data interpretation is all about calculation. We simply have to pick up the relevant numbers from the given data and do the calculation to get the required answer. So to score more marks in this section, you have to be very good in calculations. So practice more in calculations so that getting the answers here become easy. And one important point that we have learned here is, if a question, though it appears to be simple, is going to take a lot of time, that means more than 45 seconds or more than 60 seconds, the best way to solve such question would be to leave and move to the next one. So only attempt those questions which can be easily solved in less than 30 or 45 seconds. Otherwise, simply leave it and don't waste your time. Let's now take the second model from the topic of data interpretation, where we are going to discuss a question based on pie charts. A pie chart is nothing but a circle which has been drawn around an angle of 360 degrees and has been divided into different sectors, where each sector represents a particular element in the given data. Pie charts are generally useful when the percentage proportions of various elements are to be shown. It is similar to a pizza which has been cut into 4 quarters, where each quarter represents 25% of the pizza. So likewise, in a pie chart, the complete circle is cut into different proportions based on the percentages in the given data. Pie charts give a striking visual appearance, and the comprehension is very easy in case of pie charts. So let us take an example from pie charts and understand how to interpret the data from the given pie chart. Questions from data interpretation may have a single pie chart or 2 pie charts or sometimes 3 pie charts. Here we shall discuss an example based on 3 pie charts. And it is obvious that if we are able to solve a question with respect to 3 pie charts, solving for 2 or 1 pie chart becomes relatively very easy. So let's look at the question here. Now, as you can see, 3 different pie charts have been given, where each chart shows some data. For example, the first one here shows percentage of employees in each department. So here we are talking about different departments of an organization like accounts, marketing, HR, IT, production. So these are the 5 different departments. And the pie chart here shows percentage of employees in each department. So as you can see, in the accounts department, 20% of the employees work. Then 18% of the employees work in marketing department. 12% of the employees work in HR department. 15% of the employees work in IT department, and 35% of the employees work in production department. And then below this chart, it is given that total number of employees is equal to 3,600. That means the total employees that work in this organization is 3,600. Now these 3,600 employees work in various departments, which is represented by the percentages here. For example, let's say we have to find out how many employees work in accounts department. From the given chart, we know that 20% is the share of accounts department. So this 20% is with respect to total 3,600. So we can say number of employees in accounts department is equal to 20% of 3,600. Similarly, number of employees in HR, 12%. 12% of what? Total number of employees, 3,600. So in this way, from the given pie chart and the total value, we can find out the number of employees in each of the departments. And as I've already mentioned, pie chart gives a very clear visual appearance and the comprehension becomes very simple. For example, simply by looking at the pie chart, here we can say that production department has got maximum number of employees. Why? Because the share of production is maximum when compared to the remaining departments. Likewise, we can also say that HR has got minimum number of employees. Why? Because HR is only 12% and remaining all are more than 12%. So this way, comprehension from a pie chart is simple when compared to other types of graphs. And as you can see here, we can find out number of employees from each of the departments. Let us look at the second pie chart. What is the information given here? This says percentage of males working in each department. Now this pie chart is talking about males working in each department. Percentage of males in each of the departments is given to us. Again, the departments remain same: accounts, marketing, HR, IT and production. Now in accounts, there are 5% male employees. In marketing, 15%, HR 10%, IT 20%, production 50%. And below the pie chart, it is given that total number of males are 2040. That means in this organization, total number of males are 2040. Now these 2040 males have been distributed among various departments as per the given percentages. So if we have to find out the number of males in each of the departments, then we need to go for the second pie chart here. For example, let's say we have to find out how many are males working in accounts department. From the pie chart, we know that accounts has got 5% of males of total 2040. So number of males in account department will be equal to 5% of 2040. Likewise, number of males in IT department will be equal to 20% of 2040. Or any other department can be taken with respect to its percentage of the given total value. So from the second pie chart, we can find out number of males from each of the departments. So now if you try to understand the difference, the first pie chart gives number of employees in each of the departments. Employees mean here it can be male and females together. And second pie chart is about males in each of the departments. So we can find out total number of employees from first pie chart in each of the departments and male employees from the second pie chart of each department. Now there is one more pie chart which is talking about percentage of employees who recently got promoted. As you can see from the third pie chart here, it is about percentage of employees who recently got promoted. Again, it is about employees, not about males or females in particular. So this pie chart shows the number of employees who got promoted. In fact, percentage of employees who got promoted. Again, the 5 departments will be accounts, marketing, HR, IT and production, and percentages have been given to us. Total number of employees who got promoted is 1200. That means the total value for this pie chart is 1200. So now if we have to find out the number of employees who got promoted in any particular department, we need to refer the third pie chart. For example, let's say how many employees got promoted in IT department. IT department's share here is 26%. So answer should be 26% of 1200. So 26% of 1200 gives us the number of employees who got promoted from IT department. Likewise, we have to find out the number of employees who got promoted from marketing department. So marketing department's share here is 22%. So we can say that the number of employees who got promoted will be 22% of 1200 for the marketing department. So from the third pie chart, we can find out the number of employees who got promoted in each of the departments. So this is the data given among these 3 pie charts. The first pie chart shows number of employees in each of the departments. Second pie chart shows number of males in each of the departments. And third pie chart shows number of employees who got promoted from each of the departments. Before we take up the various questions that have been asked along with these 3 pie charts, let us quickly understand what are the different types of things which can be calculated from this given data. For example, from the first pie chart, we have known that the percentage of employees in each of the departments is given to us. So we can find out the number of employees in each of the departments. For example, let us do the calculations with respect to accounts department. Now, from the first pie chart, we know that total number of employees in accounts department is 20%. 20% of 3600. So we can say that total in accounts department will be equal to 20% of 3600. And this comes out to be 720. So total employees in accounts department is 720. So this 720 includes both male and female employees of the accounts department. From the second pie chart, we know that percentage of males in each of the department is given. So from this we can find out the number of males in each of the departments. Let us do the same thing for accounts department again. We know that 5% of 2040 are male employees in accounts department. So we can say that the number of males in the accounts department will be equal to 5% of the total number of males, 2040. This comes out to be 102. So we can say the number of male employees in accounts department is 102. Now if you try to understand, from the first pie chart we know total number of employees in accounts department, and from the second pie chart we know the number of male employees in accounts department. So if we take the difference of these two, we will get to know the number of females in the same department. So we can say that the females in the accounts department will be equal to total number of employees minus males. Now total number of employees here is 720 for accounts department, minus males is 102. So upon simplification we get this as 618. So we can say that 618 are female employees in the accounts department. From the last pie chart here, we know the percentage of employees who got promoted from each of the departments. So again, going by accounts department, it says 8% was the promotion for accounts department. So 8% of the total employees who got promoted, 1200, will be the number of employees who got promoted in accounts department. So it can be taken as 8% of 1200. So the promotion for the accounts department, number of employees who got promoted in accounts department will be equal to 8% of total number of employees who got promoted here is 1200. 8% of 1200 will be equal to 96. So we can say that 96 employees got promoted in the accounts department. So these are the different values that can be calculated for a given department. For example, total number of employees in accounts department 720 from the first pie chart. Number of male employees in accounts department 102 from the second pie chart. Once we know total and number of males, we can find out number of females. That is nothing but total number of employees minus number of male employees, which is equal to 618. And from the last pie chart, we can find out the number of employees who have got promoted from each of the departments. So for accounts, it will be 8% of total promotion, 1200, which comes out to be 96. So 96 employees have got promoted from accounts department. Remember friends, we only know the number of employees who have got promoted, but we have no idea that out of these 96 employees, how many are males or females. So we can only say that 96 total employees got promoted in accounts. But actually how many males and how many females have got promoted is not known to us. So these are the different things that can be known from the given data. And remember, as I've mentioned in case of tables as well, never calculate all the values in the beginning itself. Like whatever we have done here for the accounts department, same thing can also be done for various other departments. But there is no point in finding out all the values in the beginning itself without reading the given questions. What we need to do here is read the questions one by one, and whatever is required as per the given question, that can be calculated from any of these three pie charts. Let us now look at the various questions that have been asked for the given pie charts. The first question here is, if half of the employees who got promoted from IT department were males, what was the approximate percentage of males who got promoted from IT department? And the given options are 61, 29, 54, 42 and 38. So the question says, if half of the employees who got promoted from IT department were males, that means out of the total employees who got promoted in IT department, half of them were males. So what was the approximate percentage of males who got promoted from IT department? That means out of total number of males in IT department, approximately what percentage of males got promoted? Now to solve this question, first of all, we need to know what were the total employees who got promoted from IT department. Now that can be known from the third pie chart here. From the third pie chart, we know that in IT department, the share was 26%. That means the number of employees who got promoted from IT department was 26% of 1200. So we can say promotion from IT department. Total promoted from IT department was equal to 26% of 1200. Now 26% of 1200 will be equal to 312. 312. That means total employees who got promoted were 312 in the IT department. Now the question says half of the employees who got promoted were males. That means out of this total 312 who got promoted, half of them were males. So we know that number of males who got promoted, males promoted from IT department, will be equal to half of total, half of 312. Total 312 got promoted. Now half of 312 is equal to 156. So now it is clear that from IT department 156 males got promoted. We know total 312 got promoted, out of which half were males. So 156 were the males who got promoted from IT department. And from the second pie chart, we can find out the number of males who are there in the IT department. For example, for IT department, the share here is 20%. So we can say that the number of males working in IT department is 20% of 2040. So the number of males in IT department, total males for IT department can be taken as 20% of 2040. 20% of 2040. This comes out to be 408. So we know that total there are 408 males working in the IT department. Now, approximately what percentage of males got promoted from IT department? If you observe, this question is like X is what percent of Y. The males who got promoted from IT department is what percent of total males in IT department. The males who have got promoted is what percent of total males. That should be taken as males promoted by total males into 100 for the IT department. So our final answer here should be males who got promoted from IT department by total number of males into 100, and this is for IT department. So this can be taken as males who got promoted is 156. 156 divided by total number of males in IT department is 408 into 100. So by simplifying this, we can get the required answer. Now before we do the simplification, one important point that we need to understand here is look at the options and decide, can we go for approximate calculation or not? Of course, in the question itself it has been specified that approximate percentage has to be calculated. But when we look at the options, we actually get an idea that to what extent can the approximation be done. Now if you see, the options are 61, 29, 54, 42, 38. That means they are really far away from each other. So if we do an approximate calculation, definitely we will get to know which of the 5 options is correct. So without wasting our time in doing the exact calculation, let us go for approximate calculation. Now as I've mentioned in case of tables, whenever we have to do a percentage calculation, denominator should be taken as 100%. Here the denominator is 408. That means 408 is equal to 100%. Approximately we can say this is equal to 400. Let's say 400 is the denominator approximately. So total 100% here is equal to 400. Now with respect to the denominator, we need to find out what percentage is numerator. So if denominator is 100%, what percent is numerator? From denominator we know that 10% is approximately 40. If 10% is 40, 40 into what can give you 156? 40 into 4 is 160. We know that 40 into 4 is 160. So 40 into 4, 160 is approximately equal to 156. So we are here taking 40 4 times. 40 we know is 10%. 10% is being taken 4 times. 10% into 4 is 40%. So we can say that this is approximately 40%. Let me repeat it once again. Always denominator should be taken as 100%. So if the denominator here is 408, that means 408 is 100%. So 156 is what percent? Either we can go for cross multiplication, we can find out the actual answer. Otherwise, approximately we can say that 10% will be 40. Why? Because if 100% is 400, 10% will be 1/10. It will be equal to 40. If 10% is 40, with respect to that 10%, let us understand what will give us 156. We know that 40 into 4 is 160, which is close to 156. Now 40 here is 10%. So we are taking 40 into 4. That means 10% into 4, 40%. So we can say 156 is approximately 40%. Approximately 40%. Now if you look at the options, no way option number 1, option number 2 and option number 3 are close to 40%. But then option 4 and option 5 both are close to 40%. Option 4 is 42% and option 5 is 38%. So now we need to decide, will the actual answer be less than 40% or more than 40%? If you observe here, the actual denominator is 408. We have taken it as 400. That means approximately we have taken the denominator as 400. Actual denominator is 408. That means actual denominator is more. When the actual denominator is more, actual value will be less. Why? Because once the denominator increases, value decreases. So if actual denominator is more, actual value will be less. So it should be less than 40%. And moreover, even the numerator here is 156. We were getting it as 160 approximately. So numerator is also less. When numerator is less, value again will be less. So both the ways we can see that actual answer should be less than 40%. So we can say that the answer here will be fifth option, 38%. So this is how you can solve this question based on percentage. Let us now see the second question here. What is the total number of females working in production and marketing departments together? Now that's a simple one. We need to find out the total number of females in production and marketing departments together. We have already learned how to find out the females from each of the departments. The first pie chart gives the total number of employees. Second pie chart gives the number of male employees. So by taking the difference of these two, we will get the number of female employees for any given department. So here also we can find out the females in production department and females in marketing department and then add both the values to get the required answer. But friends, if you understand, there is no need to find out females separately for both the departments. Instead, we can directly find out what are the total number of employees in production and marketing department together. We can then find out total number of males in production and marketing department together, and by taking the difference of these two values, we will get the number of females in production and marketing department together. So the point here is, instead of doing individual calculations for production department and marketing department separately, we'll try to club them together and get the answer in a single calculation. So let's see how to find out the total number of employees in production and marketing together. We know that production has got 35% and marketing is 18%. So we can say that the total employees in production and marketing departments together will be equal to 35% plus 18%. 35% plus 18%. The 35 plus 18 will be equal to 53%. 53% of 3,600. Now 53% of 3,600 will be 1800 plus 108. That is 1908. So total there are 1908 employees in these two departments together. Let us now see what are the total number of male employees in these two departments together. Now the second pie chart here is about number of male employees. So for production the percentage is 50 and for marketing it is 15. So 50 plus 15, total it is 65. So we can say that total male employees, total males in production and marketing together will be equal to 50 plus 15%. 50% plus 15%, that is equal to 65%, and this 65% is for 2040. Why? Because total number of males in the organization here is 2040. So 65% of 2040. Now 65% of 2040 will be equal to 1326. So we know that total number of employees for these two departments is 1908 and total number of male employees in these two departments is 1326. So the number of females can be taken as the difference of these two values. That means total employees minus male employees will give us the number of females. So females in production and marketing together will be equal to 1908 minus 1326, which comes out to be 582. So we can say that the answer for this question here is 582. So this is how we can save some time by avoiding the individual calculations and getting the answer directly from total employees in both the departments and total male employees in both the departments. And you should be able to understand this and apply wherever possible. And one more point to be understood here is, while doing these calculations in the exam, do not write all these things: total employees in production and marketing, total males in production and marketing, and waste your time. You should be directly able to pick up the numbers, play with them and get the required answer. Avoid writing the number of steps. Cut short the number of steps so that you can get the answers as quick as possible. The third question here is, what will be the angle made at the center by the sector showing the number of males in marketing department? So we need to find out the angle that will be made at the center by the sector which shows the number of males in the marketing department. We know that the number of males or the percentage of males is shown by the second pie chart here, and the total number of males is 2040. So here the number of males or the percentage of males in marketing department is 15%. So number of males will be 15% of 2040 in the marketing department. Now, as per the given question, we need to find out the angle made at the center by the sector which shows number of males in marketing. So the sector which shows the number of males in marketing is this region. So if all these percentages are given in terms of angles, that is in terms of degrees, then we need to know what will be the angle at the center by the marketing region or by the marketing sector. Now this is a very simple question which can come only in case of pie charts. That is, we need to find out the angle made by a particular pie or a particular sector at the center. Now the simple answer here will be 15% of the total angle at the center. We know that the total angle in a circle here is 360 degrees. So when all these departments here are shown in terms of degrees instead of percentage, keeping the number of people same, we can say that the angle made at the center will be 15% of the total angle. So we can directly take it as 15% of total angle, which is 360. So the answer for this question will be 15% of 360 degrees. 15% of 360 degrees will be 36 plus 18, 54 degrees. So that is the angle that will be made at the center by this marketing region. Similarly, if the question says what is the angle made by the IT region, we can say it is 20% of 360 degrees. See, generally when it is given in terms of percentages, we take 20% of total males, 2040. But when the angle is required, we know that total angle is 360 degrees. So we can directly take it as 20% of 360, that is equal to 72 degrees. So that's how for any of these pie charts, we can find out the angle made at the center by simply taking the percentage with respect to 360 degrees. So the answer for this question is 15% of 360, that is 54 degrees. Let us now take the fourth question. The total number of employees who got promoted from all the departments is what percent of total number of employees in all the departments. So as you can see, the question here is in the form of X is what percent of Y. The total number of employees who got promoted from all the departments. This is like X is what percent of total number of employees in all the departments. This is Y. So X is what percent of Y. We know that X is what percent of Y should be taken as X by Y into 100. So X in our case is total number of employees who got promoted from all the departments, which is directly 1200 from the third pie chart. And Y here is total number of employees in all the departments, which is equal to 3600 from the first pie chart. So we can say that the answer here should be 1200 divided by 3600 into 100. The total number of employees who got promoted is 1200. Total number of employees in the organization here is 3600. So X by Y into 100. So as you know, simply we have to pick up the correct values X and Y and take it as X by Y into 100 to get the answer. Now before we do the simplification, look at the options: 56, 21, 45, 33, 51. Very clearly approximate calculation can be done. Why? Because options are not very close to each other. So approximately 12 by 36, we know that this is 1 by 3 and 1 by 3 is 33.33%, and out of the given options the best one here is 33%. So we say that option 4 is the correct answer. Remember friends, in the question it has not been specified that we need to do the approximate calculation. But since the options are given in such a way that only one option is close to the exact answer, we can take that option as the correct answer. Let us now take the last question from this given data. What is the ratio of number of employees who got promoted in HR department to the number of male employees in IT department? So as you can see here, this is a question on ratio. We need to find out the ratio of number of employees who got promoted in HR department to the number of employees or male employees in IT department. So the answer here should be HR who got promoted is to the male employees from IT department male employees. Now this value here can be taken from the third pie chart, and the second part here can be taken from the second pie chart. Now HR employees who got promoted, as you can see here, the total number of employees who got promoted is 1200 and HR is 11%. So we can say that the number of employees who got promoted in HR department is 11% of 1200. This is to the number of male employees in IT department. From the second pie chart, we know that number of male employees in IT department should be 20% of 2040. So this will be equal to 20% of 2040. Anyway, the percentage calculation here can be avoided because this is a ratio, nothing but a comparison. So whatever is common can be cancelled out. So we can say that the answer here will be 11 into 1200 is to 20 into 2040. And when we simplify this, we get the answer as 11 is to 34. It's all about doing the calculation as quickly as possible. So the answer for this question here is 11 is to 34. So that is the ratio of number of employees who got promoted in HR department to the number of male employees in IT department. So as you can see here, these questions are all about taking up the right values from the given data and then doing the calculation to get the required answer. And not only this question, in fact in all the 5 questions we have seen that it is all about doing calculations, and especially percentage calculations when it comes to pie charts. So make sure that you improve on your calculation ability and get the answers for these questions as quickly as possible. Before we move on to the next model from data interpretation, let me mention an important point regarding pie charts. The question that we have solved just now was based on pie charts where the sectors were given in terms of percentages. But in some cases, the pie chart is given in terms of degrees but not in terms of percentages. For example, here we know that this 20% if is converted in degrees will become 72 degrees. Why? Because it should be taken as 20% of 360 degrees. Total angle is 360. So 20% of 360 degrees will be equal to 72 degrees. So instead of giving the percentage here, the value that will be mentioned will be in terms of degrees. So the question simply says accounts is 72 degrees. Likewise, the remaining percentages also will be given in terms of degrees. So how to get the number of employees in each of the departments when the values have been given in terms of degrees or in terms of angles? Let's say the complete pie chart is given in terms of angles and we need to find out the number of employees in each of the departments there. Now if you see accounts, the angle here is 72 degrees. So how many employees are there in the accounts department? There what we'll do here is number of employees in accounts department. In general, if it is in percentages, what we do is 20% of 3600. So we get 20% of 3600, which will be equal to 720. But let's say if the value is given in terms of angle, so how to get the answer? So same number of employees in accounts department, there can be taken as it is 72 degrees. Now 72 degrees out of total 360 degrees. So here it should be taken as 72 out of 360. Remember both are in degrees into the total employees 3600. Again upon simplification here we get the answer as 720 employees. So if it is in percentages, we take 20% of 3600. Understand 20% is 20 out of 100. So similarly 72 degrees is out of total 360 degrees. Likewise for other departments also. For example, let's say for HR department instead of 12% it will give in terms of angle. 12% in terms of angle will come out to be 36 plus 7.2, 43.2 degrees. So angle is 43.2 degrees. Now we need to find out number of employees in HR department. Generally what do we do? 12% of 3600. But here it should be taken as number of employees in HR department. Can be taken as angle given is 43.2 degrees. So 43.2 degrees out of total 360 degrees. Why? Because total angle is 360 degrees multiplied by Total number of employees 3600. Now by simplifying this, we can get the required answer. That is, this 360 here goes 10 times. 10 into 43.2 will be equal to 432. So we can say number of employees in HR department is 432. Otherwise, if you take in terms of percentages also, we get the same answer. 12% of 3600 will be equal to 432. So this is one important point that you need to remember. If the pie chart is given in terms of percentages, directly we take the percentage of the total value. If it is given in terms of degrees or in terms of angle, then you take that angle divided by total angle, 360 degrees, into the total number of employees. Like 72 degrees by 360 degrees into 3600, or 43.2 degrees by 360 degrees into 3600. So this is one point where you need to be careful, if it is in percentages or in terms of angles. If it is in angles, we need to take out of total 360 degrees and then multiply with the total value to get the required answers. Let us now take the third model from data interpretation, which is about bar graphs. A bar graph is as shown in the figure here, where the data is plotted on the axis with the help of bars. Bar graphs can be classified into different types. One simple classification of bar graphs is vertical bars and horizontal bars. For example, the one which we see here is an example of vertical bar graph, where each bar is placed vertically. Likewise, in some cases, the bars are placed horizontally. That is, the bar will be lying horizontal from y-axis. Whether the given graph is vertical or horizontal, it doesn't make a difference in the evaluation of data. The other classification of bar graphs is in terms of the number of bars. That is, the first one can be a single bar graph, second one can be a multiple or clustered bar graph, and the third type here is stacked bar graph. A single bar graph will have only one bar at each of the points on x-axis or y-axis. And in case of a multiple or clustered graph, we have two or more than two bars at each of the points. And the third one here is a stacked bar graph. In case of a stacked bar graph, we have only one bar at each point, but each of the bars here is split into different parts. For instance, if you observe this diagram here, this is an example of multiple bars or clustered bars. We have two bars where each bar represents the population of one of the states. Instead of giving two bars at each point, we can also have a single bar where each bar is divided into two parts, and such a diagram is called a stacked bar diagram. What we do here is we place only one bar at each point, and each bar there is divided into two parts. So the length of first part gives the value of the first state, and the length of second part gives the value of the second state. Likewise, the bar can be divided into 3 or 4 parts depending on the data given there. The advantage of representing the data in terms of bars is again visual estimation. When the data is given in terms of a bar chart, it is easy for us to compare and evaluate various statistical parameters. So let's take an example of a bar diagram and see how to solve questions related to that. As you can see in the given diagram, we have a bar chart which shows population of two states in lakhs over the years. So here the population of two states, state A and state B, is given over the years, and these populations are in lakhs. So from 2001 to 2007, we know the population of two different states, state A and state B. The dark outline bar here is for state A and the shaded bar is for state B. So for each of the years, we can find out the population of state A and state B from the given bar chart. And as you can see, this is a multiple or a clustered bar graph. That is, we have two bars for two different states at each of the points. Now let us understand what is the population of state A and state B for various years from the given graph. For example, the population of state A in 2001, as you can see, 2001, the bar extends up to 40, and as given in the information, the values are in lakhs. So we can say that population of state A in 2001 is 40 lakhs. Likewise, the population of state A in 2003 will be 60 lakhs. Or population of state B in 2003 is also 60 lakhs. Population of state B in 2005 will be equal to 80 lakhs. What will be the population of state B in 2001? Now if we try to observe the population of state B in 2001, the bar here is exactly in the middle of 40 and 60. So it can be taken as 50 lakhs. So we can say the population of state B in 2001 is 50 lakhs. So as you can see here, in some cases the bar exactly matches with the horizontal lines. So it is easy for us to pick up those values. But other than that, where the bars are not matching with the lines, it may either be exactly half or 1/4 of the distance between the two lines. So accordingly, the value can be estimated. As we have seen in the first one, the bar here is extending beyond the horizontal line. So we say it is exactly in the half. As you can see, it is exactly in the middle of 40 and 60. So we can take it as 50 lakhs. Likewise, if we are able to observe that it is 1/4 of the distance, so we can take it as the total 40 and 60 difference is 20. So 1/4 of 20 is 5. So 40 plus 5, 45 lakhs. So likewise, based on the extension of the bar above the horizontal line, we can decide what exactly the value is for that particular bar. If you observe the population of state B in 2006, again here it is exactly in the middle of 80 and 100. So it can be taken as 90. Suppose if it is 1/4 of the distance, then it should be taken as 1/4 of the total difference between these two values. So 80 and 100, the difference is 20. 1/4 of 20 is 5. So we can say the total length is up to this point 80 and extension is 5. 80 plus 5, 85. So in this manner, we should be able to decide what is the value represented by each of the bars. So from this given data, we can find out the population of state A and state B for the given years. Let us now take the various questions that have been asked with this given data. The first question given here is approximately what is the average population of state A for all the given years. So that's a very simple question where we have to find out the average population of state A. Now from the bar graph, we can find out the population of state A for each of the years, and then we can find out the average as sum of all the values by number of values. So let us first of all understand what is the population of state A for each of these years. Now in the first year 2001, A is 40. We can directly take it as 40. Second year 2002, we see that the bar for A has crossed the horizontal line. It is extending beyond the horizontal line. So up to this point it is 40. Then there is an extension. Now that extension, if you observe, is almost 1/4 of the distance between these two lines. So we can take it as 1/4 of the difference of these two values. So this difference of 40 and 60 is 20, and 1/4 of 20 is 5. So the length here can be taken as 40 plus 5, 45. Remember friends, this is not exactly half. If it is exactly half, then we can directly take it as 50. Like if you observe, the population of state B is exactly in the middle. So that is 50. If that is 50, this is less than 50. And it is half of it. So it can be taken as 45. Then in 2003, the population directly here is 60. 2004, it is exactly in the middle of 40 and 60. So it should be taken as 50. In 2005, it is again exactly in the middle of 60 and 80. So it can be taken as 70. 2006, it is again only 1/4 of the total distance. So it should be taken as 60 plus 5, 65. And in the last year 2007, it is equal to 80. So the total population of state A will be sum of all these values. So 40 plus 45 is 85. 85 plus 60 is 145. 145 plus 50 is 195. 195 plus 70, 265. 265 plus 65 will be 330. And 330 plus 80 is 410. So the total population of state A here is equal to 410. Remember, if you want to solve these questions in less time, you have to add all these values without doing the calculation on paper. Like we can directly say that total population here is 410 by adding all those values mentally. So the total population of state A will be equal to 410, and this is 410 lakhs. Why? Because each of the values there are in terms of lakhs. We are supposed to find out the average population of state A. Now the average for state A can be taken as total population, that is 410 divided by the number of years. Here we have 7 different years. So number of years will be equal to 7. So this here will be equal to 410 divided by 7. Now by simplifying 410 by 7, we can get the required answer. As given in the question, approximate calculation has to be done. The question says, what is the approximate average population of state A? So let us see what is the approximate answer here. Now 410 can be approximately taken as 420. So 410 by 7 is almost equivalent to 420 by 7. We know that 420 by 7 is equal to 60. So we can say the approximate answer here will be equal to 60 lakhs. But out of the given options, no option is exactly 60 lakhs. We also understand that the actual answer should be less than 60 lakhs. Why? Because actual numerator is less. Approximately we have taken just 420. Actual numerator is less. When the actual numerator is less, actual value will also be less. So it should be slightly less than 60. And out of the given options, the one which is slightly less than 60 here is option 4, 58 lakhs. So we can say that the approximate average population of state A is equal to 58 lakhs. The second question here is, what is the ratio of total population of state A for the years 2001, 2002 and 2003 together to the total population of state B for 2005, 2006 and 2007 together. So that's a very simple question where we have to find out the ratio of state A in 1, 2 and 3 together to state B in 5, 6 and 7 together. So simply pick up the values, add them and find out the required ratio. So state A in 2001 plus 2002 and 2003 is to state B in 2005, 2006 and 2007. As I've earlier mentioned many times, don't write this and waste your time. I am writing this only to explain the problem. Otherwise, when we solve the question, this step is not required. We can directly pick up the values and get the required answer. Now A in 2001, 2 and 3 is 40, 45 and 60. So the total will be 40 plus 45 plus 60 lakhs is to B in 5, 6 and 7. Now in 2005, B is equal to 80 lakhs. In 2006, B is exactly in the middle of 80 and 100. So it can be taken as 90. And 2007, B is equal to exactly 100. So the total of B in 5, 6 and 7 can be taken as 80 plus 90 plus 100. Now 40 plus 45 is 85. 85 plus 60 is 145. This is to 80 and 90 is 170. 170 and 100 is 270. So by simplifying this, we get the ratio. Now this is nothing but 5 into 29 times and this is 5 into 54 times. So we can say that the ratio here is 29 is to 54. The third question here is, what is the percent rise in population of state B from 2003 to 2004? So that again is a very simple one where we have to find out percent rise. Now percent rise, as you have discussed in the beginning of the session, is nothing but percentage change or percentage increase. And percentage increase should be calculated as final value minus initial value by initial value into 100. So final minus initial upon initial into 100, or it can be taken as difference by initial value into 100. So percentage increase or percentage change or percentage decrease is nothing but difference of the two values upon initial value into 100. Now very clearly here we have to find out the percentage rise or percentage increase in the population of state B. Population of state B from 2003 to 2004. So both the years have been specified. The first year is 2003 and second year is 2004. That means initial value is the population of state B in 2003 and final value is the population of state B in 2004. Now population of state B in 2003, as you can see, is exactly 60 lakhs and population of state B in 2004 is exactly between 60 and 80. So that can be taken as 70 lakhs. So we find that in 2003 B's population was 60 lakhs and in 2004 it becomes 70 lakhs. So it has increased by 10 lakhs. So nothing but the difference between these two values, 70 minus 60 is equal to 10. So the answer here can be taken as difference divided by initial value. Initial value is nothing but population in 2003. Why? Because the first year here is 2003. So initial value is population of 2003, which is 60. So 10 by 60 into 100. 10 by 60 is nothing but 1 by 6. And 1 by 6 we know is 16.66%. This we know from the concept of percentages to fractions conversion. So as soon as we see 1 by 6, we should be able to answer that the percentage here is 16.66. So we can say that the population of state B from 2003 to 2004 has increased by 16.66%. So this is how we can solve questions related to percentage change or percentage increase or percentage decrease. Final value minus initial value by initial value into 100, or nothing but the difference by initial value into 100. So simply look at the difference between two values based on the initial value. Remember, always denominator is initial value, not the final value. So difference by initial value into 100. For example, for other states and other years as well, we can simply take it as final minus initial by initial into 100 or difference by initial into 100. Let's take a few more examples. Let's say what is the increase in population of state B from 2005 to 2006. Now in 2005 population is 80, in 2006 it is 90. So increase is 10 lakhs. So 10 by initial value, 10 by initial value here is 80 lakhs. So 10 by 80 into 100. 10 by 80 is nothing but 1 by 8, and from the fractions to percentages conversion we know that 1 by 8 is 12.5%. So without writing anything on paper, simply by observing the length of the bars, we can say that it has increased by 12.5%. Or whenever there is a decrease, we can take that as a decrease in the population. For example, population of state A in 2003 60 lakhs and population of state A in 2004 becomes 50 lakhs. It is decreasing. As you can see, the bar here decreases. Decreases by how much? 10 lakhs. So that is the difference. Now the percentage decrease. The actual decrease is 10 lakhs. But what is the percentage decrease? That can be taken as 10 lakhs, that is the difference, divided by initial value again. Initial value is 60 lakhs. So 10 by 60 into 100. 10 by 60 here is again 1 by 6. 1 by 6 is 16.66%. But this time it is 16.66% decrease. Why? Because population of state A is decreasing from 2003 to 2004. So simply always take percentage change as difference by initial value into 100. Like in the first year, population of state A is 40. In second year it is 45. Now here it is an increase of 5 lakhs. But what is the percentage increase? 5 lakhs by 40 lakhs. 5 by 40 is again 1 by 8. 1 by 8 is 12.5%. So we can say population of state A has increased by 12.5%. In some cases, it will be very easy for us to decide what is the percentage change by simply taking the increase in the length of the bar. For example, if you look at population of state B in 2002, it is this much of length as given by the bar. And in 2003, the bar has increased. Now, without taking up these values, if we try to compare the length of the bars, in 2002, the population of state B has got 2 portions. Let us assume the distance between 2 consecutive lines here is 1 portion. So in 2002, population of state B has got 2 portions. And in 2003, it has become 3 portions. That means half of this length has come here. Half of length has increased. Half increment is nothing but 50% increment. So as the bar has increased by half of its length, we can directly say that it is 50% increase in population. We need not even look at the values there. Let us confirm this by checking with the values. If you observe, population of state B in 2002 is 40. In 2003, it is 60. 40 is becoming 60. So 20 lakhs is the increase on initial value, that is 40 lakhs. So 20 by 40 is half. Half is 50%. So this way, whenever we have the data in terms of bar graph, when the data is represented in terms of bar charts, it is easy for us to do the estimations visually. We can directly evaluate the percentage changes visually by taking the length of the bars. But not always. Only in certain cases like increment by half or decrement by half, it will be easy for us to decide. Otherwise, again we can take it as final minus initial by initial into 100 or difference by initial value into 100. So this is one very important question which is asked in case of bar diagrams especially. That is percentage change. Final value minus initial value by initial value into 100. Now, as I have mentioned, percentage change can be of 3 types. It can be percentage change between 2 years. That means both the years are specified. Sometimes percentage change is asked only for 1 year. So we always do with respect to previous year. And in some cases, percentage change is asked over the years. That means first year and last year. So let us take 1 or 2 examples of the second and third model here. What is the percentage increase in the population of state A in 2005? What is the percentage increase in the population of state A in 2005? Now as you can see here, only 1 year is given. Percentage increase in population of A in 2005. As we have discussed, when only 1 year is given, we always do the calculation with respect to previous year. So percentage increase in population of state A in 2005 should be with respect to 2004. So 2004 the value is 50 lakhs, 2005 it is 70 lakhs. So increase is how much? 20 lakhs. 20 lakhs on initial value. What is initial value? 50 lakhs. So 20 by 50 into 100. 20 by 50 into 100 is 2 by 5. 2 by 5 into 100, and we know that 2 by 5 is 40%. So we can say that population of state A has increased by 40% from 2004 to 2005. So it's all about taking the difference on initial value and multiplying with 100. And if you are comfortable with fractions into percentages conversion, you can directly say what's the answer without doing any calculation on paper. Now let us take one example on percentage change of population of a given state over the years. For example, what is the percentage change in the population of state A over the given period or over the years? Now over the years, as we know, should be from first year to last year. So what is the percentage change of population of state A from first year to last year? Now first year the population of state A is 40 lakhs. Last year it is 80 lakhs. Now without doing any calculation, we understand that 40 is becoming 80. It gets doubled. When something gets doubled, we say that it is 100% increase. Why? Because the total bar here is getting doubled. Here we have 2 portions and here you find that we have 4 portions. So it is getting exactly double. Double is 100% rise. So we can say that population of state A has increased by 100% over the given period. Likewise, what is the change or what is the percentage change in population of state B over the given period? Now, population of state B over the period here, as you can see, first year 2001, it is exactly in the middle of 40 and 50. So 50 lakhs. First year the population of state B is 50 lakhs. And last year the population of state B is 100. So again here as well, it has got doubled. So we can say that B has also increased by 100%. So in this manner, whatever be the type of question, percentage change over the years or percentage change for 2 given years or percentage change of 1 year with respect to previous year, always it should be taken as final minus initial by initial into 100 or difference by initial value into 100. The fourth question given here is, what is the difference in the total population of state A and the total population of state B for all the years together? Now that's a simple question. Here we have to find out the difference in the total population of state A and total population of state B for all the years together. So find out the total population of A, total population of B, and then take the difference. That is what the question says. But remember friends, if we solve the question in the general way, it is going to take a lot of time. That is, finding out the total population of A, then total population of B, and then taking the difference will become a lengthy procedure. So instead of that, what we can do here is find out the difference in their populations for each of the years and add all the differences. Solving the question in this second way will help us get the answer faster. So what we do here is total population of A minus total population of B will be taken as the difference of their populations for each of the years. That means the difference in first year plus the difference in second year and so on for all the years together. So instead of finding out total of A, total of B and then taking the difference of their populations, what we do is we'll take the difference in each of the years and add all the differences. So that is nothing but A minus B in first year plus A minus B in second year and so on for all the years. So let's see what is the total difference in their populations. Then the first year we see that A's population is 40 lakhs and B's population here will come out to be between 40 and 60, so it can be taken as 50. So in first year 40 minus 50, the difference will be minus 10 plus second year A's population is 45, B's population is 40. So now A minus B here is 5 plus 5, so it is 5. Third year 60 and 60, there is no difference, so it can be taken as 0. Fourth year A is 50, B is 70, A minus B will be minus 20. Remember friends, here we have to take care of the sign because here the difference between their population is required. So we should always take the difference only in one direction, that is either A minus B or B minus A. So since first year we have taken A minus B, for all the remaining years also we have to take in terms of A minus B only. If first year we have taken B minus A, then for all remaining years we have to take it as B minus A. So that is the reason the sign is important, otherwise we may get a wrong answer. So for fourth year, as you can see, A is 50, B is 70. The difference is 20. But because we are taking A minus B, we take it as minus 20. In the next year, that is 2005, A is 70, B is 80. So A minus B will be equal to minus 10. So next year difference is minus 10. Again moving on, 2006, A is 65 and B is 90. So 65 minus 90. 65 minus 90 will be minus 25. So we can say minus 25 for the next year. And the last year here, the difference is 80 and 20. 80 and 100, that is 20. But A minus B will give minus 20. So last year it should be minus 20. Now by adding all these values, we get the required answer. So we see here that minus 10 plus 5 is minus 5, minus 5 minus 20 is minus 25, minus 25 minus 10 minus 35, minus 35 minus 25 is minus 60, minus 16 minus 20 is minus 80. So the total difference, that is A minus B for all the years is equal to minus 80 lakhs. Why? Because all these values are in terms of lakhs. So we can say that the difference in their populations is 80 lakhs. Difference here should always be positive. So A minus B or B minus A doesn't make a difference. So we can say that the total population of A and the total population of B, the difference is 80 lakhs. So remember, whenever difference between two values for all the years is required, instead of taking total of both the values and then finding out the difference, we find out the difference for each of the years in one particular direction, either A minus B or B minus A, and then add all these differences to get the collective difference for all the years together. Let us now take the last question for this given bar chart. The question here is, for which state and in which year the percent rise in population from the previous year was the highest? So here we need to find out the percent rise in population with respect to the previous year. And the question says, for which state and in which year this percentage rise was maximum. That means here for both the states, state A and state B, and for all the years 2001 to 2007, we need to find out the percentage rise with respect to previous year and then see which of these percentage rise is maximum. That means for which state and in which year the percentage rise comes out to be maximum. The given options are state B 2003, state B 2002, state A 2004, state A 2005, and the fifth option here is none of this. Because the fifth option here is none of this, we have to calculate the percentage rise for both the states in each of the years. Had the fifth option been anything else other than none of this, then our job would have been simple. Why? Because let's say fifth option here is state A in 2006. Other than none of this, if fifth option is given as state A in 2006. Now then what we can do is find out the percentage rise only for these five options: B in 2003, B in 2002, A in 2004, A in 2005, and A in 2006. Out of these five, wherever the percentage rise is maximum, that can be taken as the answer. But because fifth option is none of this, we have to do it for all the states and all the years. So here, to mark the correct answer, we should find out the percentage rise for each state and in each year. Now that actually becomes a lengthy procedure. Why? Because percentage rise, as we know, is nothing but final minus initial by initial into 100, or difference by initial into 100. Now the calculation as such is simple, but because we have a lot of calculations, the procedure here becomes a lengthy one. So what we do here is try to understand which state and in which year can be giving the maximum percentage rise simply by observing the graph. Or otherwise, what we do is first calculate the percentage rise for the given four options. For example, state B in 2003. Now state B in 2003, remember it is with respect to previous year. Always the percentage rise has to be calculated with respect to previous year. So state B in 2003 means with respect to 2002. B in 2003 is 60. And B in 2002 is 40. Now if you observe, 40 becomes 60. That means it is increasing by 20 lakhs. 20 lakhs on initial value, 40 lakhs. So 20 by 40 is half. That means we can say that the increase for state B in 2003 is 50%. Why? Because this bar here has increased by half of its length. So half of its increase is nothing but 50% increase. So we can say that state B in 2003 here, it is showing 50% increase. Now what we can do is, once we have got one of the values, that is this is 50% increase. Once we have got one of the percentage rise, with respect to this percentage increase, we can check the remaining ones. Why? Because as such, if we try to calculate each of the percentage rise, that takes more time. But now with reference to this value, we should only compare whether the remaining percentage changes are more or less. So let's now try to find out the percentage change for each of the remaining years and for both the states. Now we know that the percentage rise in first year cannot be calculated. Why? Because the previous year data is not given to us. So 2001 is anyway ruled out for both the states. We should find out the percentage rise for remaining years. Now let us first do it for state A for all the years. Now if we try to look at state A value in 2002, it is 45. In the previous year it was 40. No way it can be 50 or more than 50. Remember, here we are trying to find out where it was highest. Now we compare only with this 50%. If something appears to be more than 50%, we'll calculate only that value. Otherwise, we'll simply leave it. So if you observe, state A in 2002 is 45. Previous year it was 40. 40 becoming 45 cannot be a 50% increase. Why? Because if 40 should increase by 50%, it should become 60. So state A in 2002 is ruled out. State A in 2002 cannot be the answer. Now state A in 2003, you see that 45 has become 60. Final value is 60. Previous year 45. 45 has become 60 means increase is 15 lakhs. 15 lakhs on 45 lakhs. Previous value 45 lakhs. 15 by 45 is 1 by 3. 1 by 3 is only 33%, 33.33%, but not 50% or more than 50. So even state A in 2003 is ruled out. Now state A in 2004. In 2004 state A is 50. Previous year it is 60. That means very clearly in 2004 the population of state A is decreasing but not increasing. And here we are supposed to find out percentage increase. So no way 2004 can be the answer for state A. Why? Because here the population is actually decreasing but not increasing. Now if you look at 2005, 50 is becoming 70. In 2005, population of state A is 70. Previous year it was 50. So from 50 it has become 70. It is not a 50% rise. Why? Because 50% rise means 50 should become 75. Half of its value should increase. So 50 is becoming 70 but not 75. So even state A in 2005 cannot be 50% or more than 50%. So even this is ruled out. Again, if you go for 2006, we find that population of state A is decreasing. So that cannot be the answer. And in last year 2007, 65 is becoming 80. But this again doesn't seem to be a 50% increase. So even 2007 is cancelled. So no way state A for any of the years has shown 50% or more than 50% increase. So far our answer remains state B in 2003 only. Why? Because that is the maximum that we have got so far. But again, state B for the remaining years has to be calculated. Now we know that 2001 cannot be the answer. Why? Because previous year data is not known to us. So let us calculate state B for the remaining years. Now if you look at state B in 2002, it is 40 lakhs. Previous year was 50 lakhs. It is decreasing. Decrease here cannot be the correct answer. Why? Because we are trying to find out percentage rise. So state B in 2002 is ruled out. State B in 2003 anyway is 50%. Let us now look at 2004. In 2004, state B is 70 lakhs. Previous year it was 60 lakhs. 60 is becoming 70. It cannot be a 50% increase. It is less than 50%. So state B in 2004 is ruled out. State B in 2005, 80 lakhs. Previous year, 70 lakhs. 70 is becoming 80 again, cannot be a 50% increase. So state B in 2005 is cancelled. Then state B in 2006, 90. Previous year, 80. 80 becoming 90 cannot be a 50% rise. So even state B in 2006 is cancelled. And the last here is state B in 2007, that is 100. With respect to previous year, it was 90. So 90 is becoming 100. Again, a very small change. It cannot be a 50% change or more than 50% change. So even 2007, state B is cancelled. So we find that the maximum change here was shown by state B in 2003, and that is 50%. Why? Because 40 lakhs has become 60 lakhs. So our answer here is state B in 2003. So always for solving these type of questions, you take one reference value and with respect to that, find out the remaining ones. That means only compare whether the remaining changes are more or less. If it is more, take the new value as the reference value. If it is less, continue with the same reference value. In a similar manner, the question can also be asked in terms of lowest percentage rise. Instead of highest, the question may be about lowest percentage rise. There again, the process remains same. We take any one as the reference value and with respect to this, we try to compare with the remaining ones. But remember, when we are trying to find out the lowest percentage change, if any other percentage rise comes out to be lesser, that lesser value should be taken as a new reference and the old one should be ruled out. If it is more, then we should continue with the original reference value itself. So that's like quite opposite to what we have done here. Here we take 50% as reference and compare with the remaining ones. If we find more than 50, that is taken as reference and 50 is ruled out. But in case of lowest, if we get anything less than 50, then that should be taken as a reference value. Why? Because we want the lowest one. So as and when we get a lesser value, that should be taken as a new reference value. So in this manner, we can solve such questions where lot of calculations have to be done. Pick up any one as a reference value and with respect to that, try to compare the remaining ones. So a question which actually appears to be lengthy will become simple if you are quick in your calculation and remember, if you are very good at percentage to fractions conversion. So make sure that you spend enough time on improving your calculation ability. Why? Because data interpretation, as you have been seeing, is all about doing quick calculations. Before we take the next model from data interpretation, let me mention an important point regarding bar diagrams. As I've mentioned earlier, bar diagrams can be of different types. We can have single bars or multiple bars or stacked bars. In case of single or multiple bars, finding out the value with respect to the length of the bar is not a difficult task. But only when the bar is a stacked one. That means each single bar is divided into different portions. We need to be careful while picking up the values. So let's see how to find out the values for each of the portions in case of stacked bar. For example, let us take these two bars here, that is 65 and 80. These two bars as stacked bars. As you can see, only one bar here has been divided into different portions with the help of different types of shadings. For example, the base here has been a shading with respect to cross lines. Then we have horizontal lines as the shading part. And then we have dotted bar which shows the third portion of the stacked bar. So here the complete bar has been divided into three parts. Likewise, the next bar also has been divided into three parts. And in a similar manner, each of the bars here will be divided into three portions, where each portion represents value of that particular part. So such a bar is called a stacked bar, where a lot of information has been given within a single bar itself. So how to find out the value for each of these portions? Let's say this type of shading, the cross lines is for A, the horizontal lines is for B, and the dotted shading is for C. So let us now understand how to find out the values for A, B or C for the given years. For example, in 2007, if you observe, the cross shading, that is for state A, is up to 40. So we can say that from base to 40, that is the total length of this particular shading is 40 lakhs. So for state A in 2007, the value should be taken as 40 lakhs. Now what will be the value for state B in 2007? If you observe, state B shading starts from 40, from this length 40, and it goes up to 60. This line is 40 and this line is 60. So the distance between these two lines should be taken as the value for B. So 40 to 60 is 20. So we can see that B in 2007 is 20 lakhs. And C in 2007, it starts from 60 and goes up to 80. So C can be taken as 20 lakhs. So likewise, to find out the value for each of the shaded part, in case of a stacked bar, we should start from the base point and go up to the shading. For example, state A is up to 40. State B, we should not take from the base. We should take only from the point where the shading starts to the point where the shading ends. So 40 to 60 is 20. Again, state C is 60 to 80, that is 20. Let us see what are the values in case of 2006. In 2006, for state A, it is from base up to this point. Now this point, as you can see, is going up to middle of 20 and 40. That can be taken as 30. So state A in 2006 will be 30. Now when we have to find out state B, we start from 30 and go up to this point. Now this point here is up to 45. Why? Because this is 1/4 extended after 40. 1/4 is nothing but 5 in this case. So from 30 it starts and goes up to 45. So 30 to 45, the length is 15. So we can say that B in 2006 will be 15 lakhs. And then remaining length of the bar will be for C. So it starts from 45 and goes up to 65. So 45 to 65, the length is 20. So we can say that C will be equal to 20 lakhs. So this way, in case of stacked bars, for multiple states or for multiple parameters, only one bar is given, which has been divided into different portions with the help of various types of shading. So depending on the length of the shading, we have to find out what is the value for each of the given states or each of the given variables. And then the types of questions which are asked for stacked bars or multiple bars or single bar remains the same. It can be from averages or ratios or percentages. It is just that we should be properly able to find out what is the value for each of those bars. Let us now take the fourth model from this topic of data interpretation, where we shall discuss questions related to line graph. Like bar graphs, line graphs is also a pictorial representation of the given data. As you can see here, this is what a line graph looks like. The only difference between a bar graph and a line graph is that in case of bar graph, the data is discrete. That is, we have a bar at each point. But in case of line graph, you can see that the data is continuous as it is represented with the help of a line over the given period. Because of this continuity in the data, we have an advantage in line graphs over bar graphs. And that advantage here is that we can determine the trend or the rate of change of the given values simply by looking at the graph. For example, here if you try to observe this line, we can understand that initially the value increases and then it is decreasing and again it keeps on increasing till the last point. So that is how, in case of line graph, we can easily identify the change in the value over the given period or the trend in which the value changes over the given period. Now let us see what is given in this line graph. Now as it says, percent profit earned by two companies producing electronic goods over the years. So here the graph has been shown for two companies. That means in the same XY plot, we have got two different lines, where one line is the percent profit for company A and the other line is the percent profit for company B. Now as you can see here, the line which shows the percent profit of company A has got squares at its various points, whereas the line which shows the percent profit of company B is represented with triangles at different points. So we can easily distinguish which line is for company A and which one is for company B. For example, let's say we have to see what is the percent profit of company A in 2004. Now in 2004, we have two values here. One is 50, the other is 55. But since company A is represented by the line which has got squares on it, we can say that 50 is the percent profit of company A in 2004. Likewise, the percent profit earned by company B in 2004 will be 55. So the line which goes along with squares is that for company A and that with triangles is for company B. Let us now take the various examples that have been asked with this graph. Before we take up various questions that have been asked with this line graph, let us first understand how do we calculate profit for a given company. Now, as we can see here, the percent profit of two companies from 2004 to 2010 have been given. And in general, profit is calculated as income minus expenditure. So profit should always be taken as income of the company minus the expenditure for the company. And here we are talking about percentage profit. Percentage profit is taken as profit by expenditure into 100. It should always be taken as profit upon expenditure into 100. So these two formulae are very much required for solving various questions along with this line graph. Profit is calculated as income minus expenditure, and percent profit is taken as profit by expenditure into 100. One easy way to solve the questions from this topic would be to compare these different terms given here with the terms that we have used in the topic of profit and loss. In the discussion of profit and loss, we have learned that profit should be taken as selling price minus cost price, and percent profit should be taken as profit by cost price into 100, or selling price minus cost price by cost price into 100. So if we try to compare with those formulae, we find that the profit there is always taken as selling price minus the cost price, and percentage profit is taken as profit by cost price into 100. So if you try to compare with the various terms here, income is nothing but selling price, expenditure is nothing but the cost price. Here also we find that expenditure is nothing but the cost price. So now if you try to treat income as selling price and expenditure as cost price, solving different questions from this topic will become very easy. And as we have learned in case of profit and loss, cost price should always be taken as 100%. Here cost price is analogous to expenditure. So we can say that in this case expenditure should always be treated as 100%. Why? Because percentage profit is calculated with respect to expenditure. So always the expenditure of the company should be taken as 100%. And now the income can be calculated as income, which is equal to selling price, can be taken as expenditure plus profit. So in terms of percentage, we can say that percentage of income will be percentage of expenditure plus percentage of profit. So let's say the expenditure in terms of percentage is 100 here. So we can say that percentage of income will be 100% plus profit percent. So if the profit is 10%, income will be 100 plus 10, 110%. If the profit is 20%, income will be 100 plus 20, 120%. If the profit is 45%, income will be 100% plus 45, 145%. So very clearly remember that expenditure should always be taken as 100% and income can be taken as 100% plus profit percent. So what we have learned here is quite similar to what we have discussed in case of profit and loss. There cost price is always taken as 100%. Here expenditure should be taken as 100%. There we know that selling price in terms of percentages 100% plus profit percent. Here income in terms of percentages 100% plus profit percent. So expenditure is as good as cost price and income is as good as selling price. So if we keep these points in mind, then the questions related to this particular graph can be solved very easily. The other point that I would like to mention here is regarding the flow of the graph. If you observe the graph for company A, initially it increases, then it decreases for 2 years, and then it increases for the last 4 years. Now by looking at this graph, we should not misunderstand that initially the profit increased, and then because the line is coming down, the company is making a loss, and because the line is now going up, the company is making a profit. Remember friends, just because the graph here is coming down doesn't mean that the company is making a loss. It only means that the profit earned by the company when compared to the previous year has decreased. For example, in the first year, profit of the company was 50%. In the second year, the profit is 70%. So it only shows that profit when compared to previous year has increased. Likewise, when we go further, we find that line is coming down. Now because the line is coming down doesn't mean that company has made a loss. Company is still in profit, but the profit this year compared to the previous year is less. That is, previous year we see that profit was 70%. This year it is only 55%. So that is the reason the line is coming down. 55% here is still the profit of the company, but it is less when compared to the last year's profit. Again, when we go further, we see that the line goes down up to 45. So this doesn't mean that the company is making a loss. It only means that profit this year is 45%, last year was 55%. So when compared to last year, this year the profit is less. Likewise, again the line is going up. So company still makes a profit only, but profit when compared to previous years have been increasing. So never misunderstand that when a line which shows percentage profit comes down, the company is making a loss. It only means that the profit of the company when compared to previous year has decreased. Not only in this case, but in other cases as well, where the graph shows some percentage values, if the line comes down, it should not be treated as a decrease in the value. It only means that when compared to the last year, this year the value is less. So be careful when you are solving questions related to line graph where percentage changes are shown. Let us now take the various questions that have been asked with this graph. Remember, profit should be taken as income minus expenditure, and percentage profit is profit by expenditure into 100. And keep in mind that expenditure should always be taken as 100%, and percentage of income can be taken as 100% plus profit percent. Let us take the first question given along with this graph. The question here is, if the profit earned in 2006 by company B is rupees 8,12,500, what was the income of the company in that year? So here, profit earned by a particular company in a particular year is given to us, and we are supposed to find out the income of the same company in the same year. Now here the company which is talking about is B and the year is 2006. Now the profit earned by the company B in 2006. From the graph we know that profit earned by company B in 2006 is 65%. Because 2006 company B is represented by triangle, so it is 65%. So we can say that the profit of B in 2006 is 65%. But this 65% is equivalent to 8,12,500. Why? Because the question says profit earned by the company in 2006 was 8,12,500. So we can very clearly understand that 65% is as good as 8,12,500 in this case. And we are supposed to find out the income of the company in the same year. That means income of company B in 2006. We know that income is nothing but expenditure plus profit, and expenditure should always be taken as 100%. So income will be equal to 100% plus profit percent as discussed earlier. So income for this company here will be equal to 100% plus profit percent. Profit is nothing but 65% here. So income can be taken as 100% plus profit percent. So this comes out to be 100 plus 65, which is equal to 165%. So we can say income total is 165%, and this is equal to what has to be calculated. So now if you observe, we know that 65% is 8,12,500, 165% is equal to what? Upon cross multiplication, we get the required answer. So we can say that the income here will be equal to 165 into 8,12,500 divided by 65. And by solving this, we get the answer as 20,62,500. So that is what is the income of company B in 2006. Let us now take the second question given along with the line graph. The question here is, if the amount invested by the two companies in 2005 was equal, what was the ratio of total income of company A to that of B in 2005? So here we are supposed to find out the ratio of the income of the two companies. Company A is to company B. So the question here is, income of A is to income of B for the year 2005 is to be calculated. We know that income is nothing but expenditure plus profit. So here income of A is to income of B can be taken as expenditure of A plus profit earned by A is to expenditure of B plus profit earned by B. But in the question here, neither the profit of A nor the profit of B has been given. So we need to solve this question based on the concept of percentages. From the graph, we know that in the year 2005, the profit earned by company A was 70%. And the profit earned by company B was 55%. So let's understand that profit of A is 70% and profit of B is equal to 55%. And in the question it is given that the amount invested by the two companies was equal in 2005. Now the amount invested is same as expenditure. Investment is nothing but the expenditure. So indirectly the question says the amount invested or the expenditure of the two companies in 2005 was equal. So we can say that expenditure of A was equal to expenditure of B in 2005. Let us take this as 100%. Why? Because in general expenditure is always taken as 100%. So now we can say that income of A is to income of B will be equal to expenditure of A plus profit of A in terms of percentage. is to expenditure of B plus profit of B in terms of percentage. Now expenditure of A here is 100%. So 100 plus profit of A is 70%. This is to expenditure of B again is 100% plus profit of B is 55%. So overall we can say that the answer here will be 170% is to 155%. Percentages anyway get cancelled here. So 170 is to 155 can be taken as the final answer. Now by simplifying this further, we get it as 34 is to 31. Why? Because 34 into 5 is 170 and 31 into 5 is 155. So the final answer here is 34 is to 31. That means the income of the two companies in 2005 are in the ratio 34 is to 31. But remember friends, we are able to do this calculation only because the two expenditures are equal, and hence we can take in terms of percentages and these two percentages get cancelled. Why? Because in this case 100% of A is taken as 100% of B, but if the amount invested is not equal, then 100% of A will not be equal to 100% of B, and hence these percentages cannot be cancelled there, and if we cannot cancel out the percentages, we cannot get the required answer. And I would also like to mention that these many steps are not required for solving this question. If you can understand what is given in the question, then the answer can be obtained directly from this step onwards. That is, income of A is 100% plus 70%, income of B is 100% plus 55%. The fourth question here is, if the investments of company B in 2007 and 2008 were equal, what is the difference between the profits earned in the 2 years if the income in 2007 was rupees 27 lakhs? So here the question is with respect to company B, and it says the investments of the company in 2007 and 2008 were equal. We understand that investments here is nothing but the expenditure. So it clearly means the expenditure of company B in 2007 and 2008 were equal. So we need to find out the difference between the profits in these 2 years if the income in 2007 is rupees 27 lakhs. Now from the graph we know that the profit made in 2007 by company B is 80%. Profit of 2007 for company B here is 80%. So if the profit is 80%, income will be 180%. Why? Because income is 100% plus profit percent. So if the profit in the year 2007 is 80%, we can say income will be 100 plus 80, 180%. So income of 2007 will be equal to 100% plus 80%. That is nothing but 180%, and that income in 2007 is given as 27 lakhs. So we can say 180% is equivalent to 27 lakhs. Now from this income we can find out the expenditure in 2007. We know that expenditure should always be taken as 100%. So if 180% is 27 lakhs, 100% is equal to what? By cross multiplication we find that expenditure in 2007 will be equal to 100 into 27 lakhs divided by 180, which comes out to be 15 lakhs. That means the expenditure in 2007 or 100% of the value in 2007 was 15 lakhs. Now also from the question we know that expenditure of company B in 2007 and 2008 were equal. That means expenditure in 2007 is equal to expenditure in 2008, and that should be equal to 15 lakhs. Why? Because expenditure in 2007 we have calculated as 15 lakhs. So now we know that the expenditure for each of the years is 15 lakhs. We are supposed to find out the difference between the profits earned in 2 years. Now profit in 2007 is 80% for company B and profit in 2008 is 90%. So we need to find out the difference between these two profits. So in 2007 the profit is 80% and in 2008 the profit is 90%. We know that profit is always calculated on expenditure. Percentage profit is always calculated on expenditure. It is nothing but profit by expenditure into 100. Now as the expenditure of the 2 years are equal, we can directly take the difference as 80% difference 90%. That is nothing but 10%. So here we need not calculate the profits individually and then take the difference. Since the 100% of these 2 years, that is expenditure of these 2 years are equal, we can directly take the difference as 90 minus 80, that is 10%. So we can say the difference in profits will be equal to 10%. 10% of 15 lakhs. Now 10% of 15 lakhs is nothing but 1.5 lakhs. So the answer for this question here is 1.5 lakhs. The fifth question here is, if the amount invested by company B in 2004 is rupees 12 lakhs and the income in 2004 is equal to the investment in 2005, then what is the profit earned in 2005 by company B? So here we are supposed to find out the profit earned in 2005 by company B. From the question we know that amount invested by company B in 2004 is 12 lakhs. We know that amount invested should always be taken as 100%. So we can say that in the year 2004, 100% was equivalent to 12 lakhs. So in 2004, 100% was equivalent to 12 lakhs. That is nothing but the investment of the company, or we can take it as expenditure in some cases. Now, we know that in 2004, 100% is 12 lakhs, and from the graph, in 2004, the profit of company B was 55%. So the profit here is 55%. If profit is 55%, we can say that the income of company B in 2004 should be 100 plus 55, that is equal to 155%. 155%. So in 2004, the income of company B was 155%. And in 2004, we know that 100% was 12 lakhs. So if 100% is 12 lakhs, 155% is equal to what? Upon simplification, this comes out to be 18.6 lakhs. That is 55% of 12 lakhs is 6.6 lakhs. So 155 will be 100 plus 55. That is 12 plus 6.6, 18.6 lakhs. So income in 2004 will be equal to 18.6 lakhs. Now, as per the given question, we know that income of 2004 is equal to investment in 2005. Investment is nothing but expenditure, let's say. So we can say that expenditure in 2005 is equal to income of 2004. Remember friends, in all these questions we have been treating investment or the amount invested as expenditure. So that is the reason investment in 2005 here is taken as expenditure in 2005. That is equal to income of 2004. We know that income of 2004 is 18.6 lakhs. So we can say expenditure of 2005 is 18.6 lakhs. We are supposed to find out the profit earned in 2005 by company B. From the graph, we know that profit earned in 2005 by company B is 55%. And profit earned is always on the investment or expenditure in this case. So we can say that the profit in 2005 should be equal to 55% of the expenditure, that is 18.6 lakhs. So when we simplify this, this comes out to be 10 lakhs 23,000. So the final answer for this question here is 10 lakhs 23,000. That means the profit in 2005 is equal to 10 lakhs 23,000. So this is how, by simply following the data given in the question and the data given in the graph, we can find out the required answers. Let us now take the last variety of data interpretation, that is mixed graphs. As I've mentioned earlier, mixed graph is nothing but a combination of two or more different types of graphs. For example, here you can see we have a line graph combined with a tabular form. So this is what is called a mixed graph or a mixed variety, where two different types of data presentations have been used together. Now, as you can see here, the line graph talks about obese men, obese women and obese children from 2004 to 2009. So as you can see here, the y-axis says percentage of obese men, obese women and obese children from 2004 to 2009. Now the obese men here are represented by the line which has got circles on it, obese women by the line which have got a rhombus on it, and obese children with the line which have got triangles on it. So very clearly we can distinguish between the three values. So for example, in 2004 the percentage of obese men was 25%. The obese women were 30% and obese children were 15%. So very easily we can identify what percentage is for women, men and children from the given graph. Now the table here shows number of men, women and children in the state over the years. So from 2004 to 2009, the number of men, women and children has been given here. So from table we know the total number of men, total number of women and total number of children for 2004 to 2009. And from graph we know obese men, obese women and obese children percentages from 2004 to 2009. That means very clearly by the combination of these two, that means percentages in the line graph and totals in the tabular form, we can find out the number of obese men, number of obese women and number of obese children for any of the given years. For example, let's say we have to find out how many men were obese in the year 2004. Now we know that in 2004 total men were 54,000 and the percentage of obese men in 2004 was 25%. So we can take it as 25% of 54,000. Similarly, let's say we have to find out the number of obese children in 2008. Now in 2008, the percentage of obese children is 10. So 10% of the children in 2008 were obese. And total number of children in 2008 is 20,000. So 10% of 20,000 is 2,000. That means number of obese children in 2008 is 2,000. Likewise, it can be done for any type of person and for any of the given years. Let us now take the various questions that have been asked along with this data. The first question given here is, what was the approximate average of obese men, obese women and obese children in 2007? So here we need to find out the average of obese men, women and children in the year 2007. Now we know that from the given graph and the table we can find out the number of obese men, women and children for any of the given years. So let us find out each of those values for the year 2007 and then take the average. So obese men in 2007 can be taken as, in 2007 the percentage of obese men is 35 and total men in 2007 is 66,000. So 35% of 66,000 will give us the number of obese men in 2007. So that is 35% of 66,000. Then obese women in the year 2007. The percentage given here in 2007 for women is 25% and the number of women in 2007 is 54,000. So we can take it as 25% of 54,000. And lastly, the obese children in the same year 2007 can be taken as, 2007 the percentage of obese children you see is between 10 and 15. This triangle here exactly lies between 10 and 15. So we know that it can be taken as 12.5. So 12.5% of total children. Total children here is 16,000. So this will be 12.5% of 16,000. Now by simplifying all these values and taking the average, we can get the required answer. So 35% of 66,000 can be taken as 33,000 minus 9,900. That is equal to 23,100. 25% of 54,000 is 13,500. And 12.5%, we know that 12.5% is 1 by 8. So 1 by 8 of 16,000 will come out to be 2,000. Now, average number of obese men, women and children. Average can be taken as the total of all these values divided by 3. Now the total of all these values here will be 23,000 and 13,000, 36,000 plus 2,000, 38,000 and 100 and 500, 600. So 38,600, 38,600. 38,600 when divided by 3 will come out to be 12,866.66. But as the question says, approximate average is required. So approximately 12,866.66 can be taken as 12,867. So we can say that the answer for this question is option number 3. That is 12,867. So it's all about picking up the right values, simplifying and doing the calculation to get the required answer. The second question here is, the number of obese men in 2009 was what percent of men not suffering from obesity in the same year? So if you observe, this question is in the form of X is what percent of Y. The X here is the number of obese men in 2009 was what percent of, and the Y here is men not suffering from obesity in the same year. That means in 2009. So X is what percent of Y? We know should be taken as X by Y into 100. So X here is obese men in 2009 and Y is the men who were not suffering from obesity in 2009. So the answer here should be men suffering from obesity. Obese men, and Y is the men who are not obese. Let's take it as non-obese men. So obese men by non-obese men for the year 2009 into 100. Now we know that the obese men in 2009 will be equal to 37.5%. We find that this particular point here is between 35 and 40. So it can be taken as 37.5. So 37.5% of total men in 2009, that is 78,000. So that will give us the number of obese men. Now the point is how to find out the men who are not suffering from obesity. See, the men who are not suffering from obesity can be taken as total men minus men who are suffering from obesity. So we can find out the obese men as 37.5% of 78,000 and men who are not suffering from obesity as 78,000 minus men who are suffering from obesity. So that will give us non-obese men. And then obese by non-obese into 100 will give us the required answer. But friends, that's the general way of solving the problem, and it takes a lot of time to do all those calculations. But smart students will get the answer without referring to the table, directly by looking at the given percentage here. We know that in the year 2009, 37.5% of the men are obese. Now it is obvious that if 37.5% men are obese, the remaining 62.5% men are not suffering from obesity. Let us assume that the total men is 100%. Total, as we know, can always be taken as 100%. From the graph, we know that obese men is 37.5%. So the men who are not suffering from obesity will be total minus obese men. So non-obese men, as the term that we have given here, non-obese men can be taken as 100 minus 37.5, that is equal to 62.5%. So we know that obese men will be 37.5% of 78,000 and non-obese men would be 62.5% of 78,000. And we have learned very well that whenever there is something common in numerator and denominator, that need not be considered. So we need not worry about this 78,000 here. We can directly take up these two values as x and y respectively and get the required answer. So the answer here will be equal to 37.5 divided by 62.5 into 100. Remember friends, it is actually 37.5% of 78,000 and this is 62.5% of 78,000. But because we understand that 78,000 gets cancelled, directly take up only those things which can affect the answer here. So that is 37.5 and 62.5. Now 37.5 is 12.5 into 3 and 62.5 is 12.5 into 5. So the value here is 3 by 5 into 100. We know that 3 by 5 is 60%. So the answer for this question here is 60%. So this is how we can solve this question in a smart way by simply taking the value that is given in the line graph. So try to avoid lengthy procedures and get the answers as quickly as possible. And as I've been mentioning in all the questions, try to cut short the number of steps. If you have really understood the question, these 3 steps here are not required. We know that total is anyway 100%. From that 37.5% can be subtracted and it will be equal to 62.5. We need not write these things on paper there. The third question given here is, what was the ratio of obese women in 2006 to the obese men in 2008? So here the question is based on ratio. We have to find out the ratio of obese women in 2006 is to obese men in 2008. So by simply taking up the right values from the given data, we can find out the ratio here. Now we know that the percentage of obese women in 2006 will be 20% and the total women in 2006 is 60,000. So the number of obese women in 2006 can be taken as 20% of 60,000. So this will be equal to 20% of 60,000 is to obese men in 2008. The percentage of obese men in 2008 is exactly between 25 and 30. So that can be taken as 27.5%. And the total men in 2008 is 70,000. So the number of obese men in 2008 can be taken as 27.5%. That is 27.5% of 70,000. So this will be equal to 27.5% of 70,000. Now by simplifying this, we get the required answer. So zeros anyway get cancelled here. This can be taken as 2.5 into 8 and this is 2.5 into 11. So 8 into 6 is 48 and 11 into 7 is 77. So the answer here is 48 is to 77. The next question here is, what is the difference between the number of obese women and obese children together in the year 2006 and the number of obese men in the same year? So here we need to find out the difference between the number of obese women and obese children together and the number of obese men in the year 2006. So that means we first of all have to find out obese women, obese children and obese men in the year 2006 and then take the difference as given in the question. Now, from the data here, we know that the percentage of obese men in 2006 is exactly between 30 and 35. So that can be taken as 32.5%. So the number of obese men in 2006 will be 32.5% of total. That is 63,000. So obese men in 2006 will be equal to 32.5% of 63,000. This will come out to be 20,475. Then the number of obese women in 2006, percentage here is equal to 20 and the total women is 60,000. So obese women can be taken as 20% of 60,000. That comes out to be 12,000. And lastly, the obese children in the same year, that means obese children in 2006. Now the percentage of obese children in 2006 year is given as 25%, and the total children in 2006 is 12,000. So it can be taken as 25% of 12,000, which is equal to 3,000. So now we know the number of obese men, women and children for the year 2006. Now as given in the question, we have to find out the difference of obese women and children together and the obese men. So first of all, let us add these two values. That means obese women and children together. 12,000 plus 3,000 will be equal to 15,000. So obese women and children together. That means obese women plus children here is equal to 15,000. Now we are supposed to find out the difference of this value with the obese men. Obese men we know is 20,475. So 20,475 minus 15,000 will give us the required answer. As the question says, difference between women and children together and men. So the difference of women and children with men has to be calculated. So that comes out to be 20,475 minus 15,000, which is equal to 5,475. So again, as you see, a question purely based on calculation ability. The faster you do your calculation, the quicker you get your answer. So practice on calculations and make sure that you solve such silly questions as quickly as possible. Let us now look at the last question from this data here. What was the total number of children not suffering from obesity in 2004 and 2005 together? So here we need to find out the number of children who were not suffering from obesity in the given years, 2004 and 2005. Now from the graph we know that in the year 2004, 15% of the children were affected by obesity. Now if 15% were affected by obesity, it is very clear that the remaining 85% of the children were not suffering from obesity. Likewise, in the year 2005, we can see that 10% of the children are obese. That means they are suffering from obesity. So if 10% of the children are suffering from obesity, it is obvious that the remaining 90% were not suffering from obesity. So now we know that in 2004, 85% of the children were not affected by obesity, and in 2005, 90% of the children were not affected by obesity. So by taking the total of these two values, we get the required answer. So in 2004, the children not suffering from obesity can be taken as 85% of total children. The total children in 2004 is 15,000. And in 2005, the children who were not affected by obesity will be 90% because 10% are affected from obesity. So remaining 90% will not be affected. So that is 90% of the number of children in 2005. That is equal to 21,000. So this comes out to be 12,750, and the second value here is 90% of 21,000. That is nothing but 21,000 minus 2,100, 18,900. Now by adding these two values, we get the required answer. Why? Because we need the total number of children not suffering from obesity in 4 and 5 together, 2004 and 2005 together. So 12,750 plus 18,900 will be equal to 31,650. So this is the answer for the last question here. That is 31,650 children were not affected by obesity in the year 2004 and 2005 together. So this is how we solve the questions related to mixed graphs. It is all about understanding the given data properly, picking up the right values and doing the calculations as fast as possible. So with this mixed graphs, we have finished the complete data interpretation part. As you have seen, all these type of questions, whether it is tables or line graphs or pie charts or mixed graphs, it is all about calculations. So make sure that you practice enough on calculations and various questions from this topic of data interpretation, so that this becomes a trump card for you in your bank exams. That's all from this topic. See you in the next session. Thank you.